First things first, according to Einstein's theory of relativity, an immovable object can't really exist. Why? Because motion is always relative. Think about it. If you're sitting still in your house, it feels like you're not moving. But if I hop on a rocket and fly past Earth, from my perspective, you're the one flying by while I remain perfectly still. Physics doesn't favor one frame of reference over another, so the concept of something being truly immovable is impossible. What people usually mean, though, is an object that can't be moved no matter how much force you apply. Something unshakable, something with infinite resistance. Newton's second law tells us, acceleration equals force divided by mass. If you want an object that cannot accelerate, you'd need it to have infinite mass. No matter how strong the force is, when you divide by infinity, you get zero acceleration. So an immovable object isn't literally frozen in space. It could still be moving, but once it moves, nothing can alter its speed. If it's still, it stays still. If it's already moving, it keeps going at that speed forever. Now let's flip it. What does it mean to have an unstoppable force? In physics, every fundamental force, gravity, electromagnetism, the strong and weak nuclear forces, works by transferring momentum. Particles like photons, gluons, or even gravitons bump into things and nudge them. The only way to avoid being affected is to not interact at all. In a sense, all forces are unstoppable, because every interaction changes momentum, even if only a tiny bit. But when people talk about an unstoppable force, they usually mean something barreling toward you that simply cannot be slowed down. In other words, an object whose velocity can't be altered. Wait a second. Doesn't that sound exactly like what we just described for an immovable object? Yes. The unstoppable force and the immovable object turn out to be the same thing, just viewed from two different perspectives. But here's the catch. For something to have infinite mass, you'd need infinite energy. That means it would collapse into a black hole so massive that everything in the universe would already be trapped inside it. Clearly, that doesn't exist in our reality. Still, let's imagine it for the sake of the paradox. What if we had objects with infinite mass moving through space? They would never slow down, never speed up, never change. If two such objects were on a collision course, what would happen? Since neither could alter its velocity, the only possible outcome is that they'd pass right through each other, completely unaffected, as if the other didn't even exist. Here's another fun thought. If we really had something with infinite mass, we could break the second law of thermodynamics, generate infinite energy, create time travel loops, and even build a perfect utopia powered by endless motion. Of course, that's pure science fiction, but it shows how powerful and dangerous the idea is. So, in the end, the paradox of the immovable object and the unstoppable force isn't really a paradox at all. Both ideas describe the same impossible thing, an object with infinite mass. And since infinite mass can't exist in our universe, the answer is simple. Neither of them can. The next time you hear the question, what happens when an immovable object meets an unstoppable force? You'll know the truth. They just pass right through each other because in physics they're really the same thing.